Hello everyone, this is my physics project and my topic is degrees of freedom. So let us understand what degrees of freedom means in general terms. The number of direction in which a particle can move freely is defined as its degrees of freedom. If you take a particle, this particle can move in numerous directions. Okay, so the number of this numerous direction in which this particle can move freely is defined as its degrees of freedom. So let us see different examples to understand degrees of freedom. The first example is the rope walkers. They can walk only in one axis. So this rope walker can walk along this axis. So therefore the degree of freedom is 1 in his case. Now the second example is the carom board striker. Carom board striker can move along x and y axis. This carom board striker can move along this axis and this axis. Therefore the degree of freedom is 2. So let us understand degrees of freedom in terms of coordinates. The number of independent coordinates required to specify completely the position and orientation of a particle in space is defined as its degrees of freedom. So let us consider a particle which is moving along the x and the y coordinates. The x and the y coordinate. So this x doesn't depend on this y and this y coordinate doesn't depend on this x. This is what independent coordinate means. So the number of independent coordinates required to specify completely the position of this particle, that is where this particle is moving along the x and the y coordinate, and the orientation, that is the rotation of the particle along these two coordinates is defined as its degrees of freedom. Now let us take an example. Consider a molecule. Okay, so this molecule can move upward, backward, forward, upward, downward, left and right. So it can move along the z coordinate, the x coordinate and the y coordinate. It can show motion in three axes, that is x, y and z axis, that is x, y and z axis, backward, forward, upward, downward and left and right. Formula to find degrees of freedom. If one free particle has 3 degrees of freedom, then n free particle will have 3n degree of freedom. See, if one free particle has 3, then ultimately n free particle will have 3n degree of freedom. So if we have n free particle with k constraint, if we have n free particle, that is degree of freedom 3n. So if we have n free particle with k constraint, we have to minus the k constraint, which will give us the degree of freedom. Okay. If we have n free particle with k constraint, therefore 3n minus k is equal to f, that is degree of freedom. Here n is the number of particles that or the atoms and k is the constraint or the restrictions. Okay, so this formula we have to remember, 3n minus k, which is equal to f. Now, degrees of freedom arises due to three motions. First one, translation motion, then rotational motion and vibrational motion. Degree of freedom of translation motion. These are due to the translation motion of molecules. Maximum number of translational degree of freedom is 3. irrespective of that the molecule may be monatomic, diatomic or polyatomic. These are present at ordinary temperature. So, the degree of freedom arises due to the translation motion along the x, y and the z axis. So, the degree of freedom is 3 in case of translation motion. Irrespective of that, the molecule may be either monatomic, diatomic or polyatomic. In this case, it is diatomic. Degrees of freedom of rotational motion F. These are due to the rotational motion of molecule about an axis passing through the center of mass of the molecule. This depends upon the structure of the molecule, and these are also present at ordinary temperature. So these are due to the rotational motion of the molecule about an axis passing through the center of the mass of the molecule. These are due to the rotational motion about an axis passing through the center of the mass of the molecule. Degrees of freedom of vibrational motion Fv. These are due to the vibration motion of a molecule about its equilibrium position. Okay, equilibrium position. Their number depends upon the structure of the molecule and are present at high temperature. Okay. Now we have three kinds of gases. First one is the monoatomic, which consists of one atom, and the second one is the diatomic gas, which consists of two atoms, and the polyatomic gas, which is the linear, which has more than two atoms. In this case, it's diatomic, that is three atoms. This is the linear one, non-linear one. Now, so let us take the example of all three types of gases and let us find out the degrees of freedom in each case. So the first one, that is the monoatomic gas, He, helium, neon, argon, etc. Consider monoatomic gas. Okay, so this atom can move along this direction, that is x, y and z axis, or anywhere in the middle between the xyz coordinate. So that's why the degree of freedom of translation motion is 3, because it can move along these three directions. Now the degree of freedom of rotation motion is 0. Why is it 0? Because the size of the monatomic gas molecule is negligible, so the moment of inertia will be 0, and that's the reason we don't consider the degree of freedom in case of the monatomic gas. So the degree of freedom in case of the monatomic gas is 0. Now the degree of freedom of vibration motion. So 3n minus k, this is the formula. N is the number of particles. So in this case it is 1 minus 3, k constraint. 3 plus 0 is 3, which is equal to 0 degree of freedom. So the total degrees of freedom for monoatomic gas molecule is taken to be 3 plus 0 plus 0, which is equal to 3 degree of freedom in case of the monoatomic gas. Second one, that is the diatomic gas. So this diatomic gas can move along the x-axis, the y-coordinate and the z-coordinate. So the degree of freedom of translation motion is 3. Now degree of freedom of rotation motion is 2. How is it 2? So if we place this diatomic molecule on the x-axis, it can rotate along z-axis and y-axis. but not on x-axis because its moment of inertia at x-axis is 0 because it is present on the axis. So that means it has degree of freedom of rotation motion too. Now, degrees of freedom of vibration motion. We have to use the formula 3n minus k. 3n is 2 because it is diatomic, that is 2. Then minus 5, that is k. 3 plus 2, which is equal to 5, which will give us 1 degree of freedom. So total degrees of freedom for diatomic gas is 3. 3 plus 2 plus 1, which is equal to 6 degrees of freedom. Now the second one, that is the polyatomic gas. Example CO2, H2O, CH3Cl, etc. So the first one, that is the linear example CO2. So this molecule, linear polar triatomic molecule, can move along the x, y and z axis. So the degree of freedom of translation motion is 3. Now the degree of freedom of rotation motion is 2. It is same as that of the diatomic gas, wherein the x-axis uh, there is no rotation because the moment of inertia on this axis is 0, and that's why it is 2. Now, degrees of freedom of vibration motion 3n minus k, n is 3, k is 5, 3 plus 2 which is 5, then 9 minus 5 is equal to 4 degrees of freedom in case of the vibration motion for linear triatomic gas. Then total degree of freedom of linear polyatomic gas is equal to 3 plus 3 plus 2 plus 4, which is equal to 9 degrees of freedom. Now the non-linear H2O. So this non-linear triatomic molecule can move along xyz direction, so the degree of freedom is 3, and the degree of freedom of rotation motion is 3. Why is it 3? In this case it is linear, so on the x-axis the moment of inertia is 0, but in this case it is non-linear, so this molecule will have a moment of inertia on this axis, and that's why it can rotate along the x-axis also. So the degrees of freedom will be 3. Now degrees of freedom of vibration motion 3n minus k. 3 is 3 because it is diatomic, minus 6. 3 plus 3, 3 plus 3 is a 6. Then 3 3s are 9 minus 6, which gives us 3 degrees of freedom. Now total degrees of freedom of non-linear triatomic molecule gas is equal to 3 plus 3 plus 3, 3 plus 3 plus 3, which is equal to 9 degrees of freedom. So let us summarize the things that we learned. So in the beginning, we learned about the definitions of degrees of freedom, the general and the coordinate in terms of coordinate. Then we took different examples to understand degrees of freedom. Then we learned about the translational, the rotational and the vibration motion. Then we took the examples of different types of gas molecules, the monoatomic, diatomic, triatomic, linear, triatomic, non-linear. Then we found out the degrees of freedom in each case. So the monoatomic gas, the total degree of freedom was 3. Then the diatomic gas, it was 6. Then the triatomic linear gas was found out to be 9, and the triatomic nonlinear gas was also 9. So this is all about degrees of freedom.